Okay, hello everyone, and a big welcome to our POSPac Assure webinar today. We launched this new product, POSPac Assure, just 10 days ago and announced that at the GeoWeek conference. So today we're showing you how to get the ultimate in GNSS INS checking. I'm Nico Jäger, the Applanix POSPac product manager, and I'm delighted to be your host today. We have also Hani with us, our POSPac Cloud Development Manager, who will demo the Applanix Assure web application and assist me with questions that you may have. Santia is also with us from our marketing team. If you're looking for more great content from Trimble Applanix, please check out our past webinars in our webinar center. So just go on our website and search for webinar at applanix.trimble.com, and you will get access to other great webinars. Okay, let's keep this going. First, some words about the logistics today. The presentation will probably take about 30 minutes, and then we have like a 10 minutes live demo by Hani. And we'll have another 10 minutes or maybe 15 minutes for a Q&A session. So I guess we're kind of flexible as long as we keep the things within an hour time window. The webinar will be recorded and shared with you later on. All attendees are muted, but should you have any questions during the session, just use the Q&A box at the bottom, and we'll try to answer your questions right after the presentation, or if you don't succeed right in the presentation, we'll follow up in an email with you. So in terms of the agenda, we first will speak about what is POSPac Assure, then have a look at the input, deliveries, and features that we service here, what type of processing modes you can use in POSPac Assure, the supported business plans, some words about the report analyzers, because at the end of the entire processing or at the end of the delivery of the final product, you probably want to analyze your results. Then I'll mention a few additional features that are exciting, I think, to share with you. And at the end, we get a little bit of a summary, and then Hani will take over for the demo before we come to the Q&A session. So what is POSPac Assure? POSPac Assure is a user-friendly web application to generate GNSS INS real-time quality reports, calibration estimates, and or ground truth data by leveraging our POSPac Cloud engine. And this POSPac Assure web application shall assist our integrators rapidly with high level of automation and precision. We are supporting basically all GNSS INS land and marine products. We're also supporting real-time products such as the BD992 INS, the X992 ER, as well as our real-time fleet. And in addition to the land and marine products here, we also support the PX1 system from the advanced air mobility sector. For the real-time products that I mentioned already, they can leverage the features real-time QC and calibration mode, while the PX1 system can leverage the real-time QC mode only. All the rest of the systems that we support can really use all three features, and I will explain a little later what the features are about. So who is basically our target group here? We target customers who need an easy tool to verify their platform real-time performance. So think about, you have a GNSS INS system, you collect the data for whatever business line that is, and you want to see what is my performance during the data acquisition, so in real time, without going into any desktop software. You could use POSPac Assure for that purpose. Or customers who need a simple tool to verify the GNSS INS integration. So whenever it comes to a GNSS INS hardware system that needs to be integrated, there are a couple of parameters that need to be calibrated, such as lever arms. So this is an easy tool to verify that type of the integration. Then customers who don't want to install, learn, and use POSPac MMS desktop software, because that application is easier to use compared to obviously any desktop software that you can install locally. And finally, also for customers who require ground truth reference data. However, in that case, I have to say this is not designed for like usage in a high production environment. This is really more for sporadic testing of data or even creation of an SPED file, not like for a high fleet environment. So customers who want to streamline and automate like a high production environment, they shall rather use our POSPac Cloud API. So basically pursuing a tighter integration. And when I say ground truth, and this is really the generation of our famous SPED file, but I'll come to that a little later. So the three features I mentioned already, the features kind of. So we are servicing three main features here. The first one is called the real-time QC. So real-time QC would generate you a tailored report, like a PDF file that contains plots about the real-time performance and quality. Not only plots, but also tables and some values. So it's at the end, it's going to be a PDF report that gives you really a good quality assessment of your real-time application. And the second feature that we serve here is called the calibration mode. So in case of customers want to calibrate their installation parameters, such as the lever arm for the GNSS antenna, the offset vector between both antennas, if you have the GAMS working on your system, or the lever arm to the DMI, which is the odometer attached to the wheel in the land application, plus the scale factor, or for the autonomy industry might be interesting, the heading bore side angle between the vehicle and the inertial measurement unit. Such parameters that you initially need to enter during the system setup can be calibrated by using this calibration mode feature. And the last feature here is the ground truth feature. Ground truth means you basically get an SPED reference file back. The SPED reference file is the post-processed GNSS INS solution, and SPED stands for the smooth best estimate of trajectory. So indeed, you do a post-processing step to get the best quality of your GNSS INS trajectory. The workflow itself, as soon as you play around with it, you will realize it's basically very simple. So after you registered and you're logged in with your account, you can simply drag and drop the rover files over a map. That creates automatically a project. And if you want, you can also load a base station file and select the processing mode at the end, and then you submit your project. After you submitted your project, you will see the mission popping up in your history, on your history side, and then you can, after successfully process your data, you can actively download your mission. But at the same time, when the mission is completed, you will also obtain an email with the attached delivery files in a zip file format. Now here you can see the user interface. As I said before, you simply drag and drop the rover files into the map. It automatically creates a project name from the file name of your rover files, or if you want, you can obviously overwrite the project name. And the trajectory is then overlaid over the map so you can see the trajectory. At the same time, the integration here will even suggest a certain processing mode of your data, depending on the correction data that we have in our database and that we are aware of. The user can take that suggestion or select any other processing mode that he finds suitable. In addition to the processing mode, when it comes to your own base station that you want to load, you can also leverage the Trimble Centerpoint RTX survey in functionality that is capable to determine the coordinates of your base station. And then you can click on the project history page. That's something that Henny will demo a little later. You can see basically your projects that you uploaded, the project ID, and then the status of the project. So whether it was successful, failed, it's still in processing mode. And at the end, under the action column, you can download actively your project, from the cloud. But as I said before, once that was successful, you're also going to be notified with the attached delivery files in your email account. So I think the benefits become very clear already here. As I said, this is a very easy to use web application. There's not much of an interaction, and it will create very fast deliveries to you. There's no POSPac desktop installation and learning needed, right? In addition, our business model is pursuing the subscription model. So it's going to be like a monthly subscription that you can also cancel on the monthly basis. And we also sell so-called add-on tokens if you need to process more data that is part of the contingent of the current subscription model. But I will explain that a little later as well. And of course, the standard benefits when it comes to cloud products is we always run the latest and greatest. So there's an automatic software update happening, obviously. We have a high standard of security. We have a redundant cloud environment. And obviously, you also don't hassle with any software licensing when it comes to a cloud solution. Now, what are the input files, deliveries, and features? So in terms of the input files, the minimum that you need to upload is really your rover data. We support the T04 file, which is from our latest hardware generation, such as the AP Plus products. But we also support the legacy POS files from our older hardware generation. So that's the minimum that you need to upload. And then you can leverage either GNSS corrections that we supply to do a better processing, or you can also optional upload your own base station if you want to. In terms of the deliveries, that will always be like coming in a zip file with a bunch of files in it. I didn't list all of the files here, but let's see, the most important are here. So for the real-time QC feature, you'll get a tailored PDF report with all the information that you need to understand or assess basically the quality of your real-time data that you acquired. In addition, you'll get a KML file, KMZ file only if you have T04 files. You also get the real-time navigation solution, like the vehicle navigation or reference navigation solution, which is the RNAV or VNAV file, and along with this bunch of log files if you want to have a deeper dive into your data analysis. Now, the second one was the calibration mode. Same here, you can see same number of files, but the report obviously would look a bit different. You have additional tables that give you the calibrated values, for instance, maybe also some more plots, because when we calibrate something, we need to post-process something. In the real-time feature, there's nothing really post-processed. And then finally, ground truth. This is really when we create the aspect file. So of course, one of the files that we deliver is the aspect file. And in addition to our aspect file, we also deliver the standard ASCII file that contains position orientation information. In the tailored report for ground truth, that obviously again looks different than for the other modes, we also have a feature that right now compares the real-time navigation solution against the post-processed navigation solution. So that might be very interesting for integrators to see, okay, what is the difference really between my real-time performance and my post-processed performance? So that kind of feature runs all the time automatically, and you can see the difference in the plots from the PDF report. Now, the calibration mode, what's specific about the calibration mode? One thing that is important to understand here is that the initial values that we want to calibrate are basically coming from the real-time setup. So the user will need to make their initial setup in the browser user interface or in our POSView controller. And we basically take those values and we float all of those values to enable the calibration process. So there's no interaction on the web application itself where you can enter any lever arms or any rotation values. That needs to be done on the system itself. And when I speak about lever arms, again, it's a GNSS antenna lever arm, IMU lever arm, DMI lever arm, scale factor for DMI, and rotations that apply between the vehicle frame and vehicle frame IMU or IMU and reference frame. So at the end, once you've done that and everything was calibrated, you would take the calibration values back and correct your setting on the system. Again, either through the browser user interface or with the POSView controller software. Now, for the ground truth mode, it's quite the same thing. The assumption still is that everything was set up on the system. And in this case now, the assumption is that everything is set up properly. So you have done a proper calibration of all of those parameters, and they have been entered into the system. And what we are doing then here is we are going to fix all of those lever arms. We're not floating them to create really the ground truth reference. So we are going to create an unbiased, precise GNSS INS trajectory. And we are floating nothing because we want to make sure there's no additional noise in it. And again, I repeat, the user interface does not allow to enter any of those lever arms. That needs to be done on the system itself before it's presented to POSPac Assure web application. Now, what type of processing modes do we have? I think the most famous one, the most interesting one, is the PPRTX mode. I'll have some more words later on about this one. But yeah, that's using a worldwide cloud correction service from Trimble, where the customer does not need to provide any base stations. And we're still obtaining a centimeter level accuracy by using all of the satellite navigation systems. The other mode that we support is the smart base mode. This is where multiple base stations are being used, and they are defining a network of stations that are surrounding your mission area. We're kind of applying a VRS concept, like a virtual reference concept here. And in case of that processing fails, we even have a fallback to the single base mode. As long as a base station is nearby and we can make use of it and the smart base concept fails for whatever reason, we still rely on published base stations. There's a fallback that it can run in the single base mode. That brings me to the other ones, as I said. So single base is obviously an option. You can run single base mode with the auto download functions, where the engine is searching for available base stations. And we're supporting more than 10,000 base stations right now worldwide. And by the way, there is a free of charge app. It's called the TGAP app, where customers can see the base station that we support worldwide. And the last one is, again, single base mode, but in this case, the user will have to provide the base station. That's a very traditional approach. Baseline length should be within 20 kilometers. And again, it comes kind of from the user. Single base processing would also be supported in case of the real-time system had locked RTK corrections. That's kind of also single base processing, but the software can detect that and will use the RTK correction data. RTK correction data is typically like CMR, CMRX corrections, or RTCM corrections. Okay, so for the ground truth mode, it's quite important to understand what the export frame is like. So we're going to deliver you the SBIT file. We're going to deliver you an ASCII file that even outputs the solution in the appropriate UTM zone. But what is the frame behind it? And if I say frame, then I refer to things like WGS 84, NUT 83, ETRS 89, ITRF frames, etc., etc. So this export frame depends on the processing mode that you select. and or the base station coordinates that you use. So for the first three modes here, get the pointer here. So like the single base mode with the auto download function, oops, that's not what I wanted, or the smart base mode, or the single base RTX mode, where the base station is served in with the RTX technology, or the PPRTX mode. In that case, the final trajectory is coming in the ITRF 2020 system at the epoch of 2015, which is the original date or original epoch of realization of that reference system. And the ITRF 2020 is actually the latest international terrestrial reference frame. Now, in case of the user comes with his own base station and they enter the base station coordinates, or they trust the coordinates from the Rhinix file header, in this case, the generated trajectory will be tied to the user coordinates being used or tied to the Rhinix coordinates being used. And the same applies, obviously, if the user does process with the onboard RTK corrections or in the so-called autonomous mode. In the autonomous mode, the engine will automatically detect what sort of corrections are available and will apply them during the processing. So again, this is kind of hard-coded. You just need to know that. There's no interaction with the user interface to select any specific frame that you want to see. Now, that brings me to Trimble RTX. I mentioned already PPRTX. So what is Trimble RTX? In this context, Trimble has a network of GNSS tracking stations worldwide, and we speak about 100+ stations collecting data day and night. And all data are processed in a control center, and via a smart algorithm, it creates a set of correction data for the rover. It basically corrects for the standard GNSS error budget, such as for satellite orbits, clock errors, atmospheric errors triggered by the ionosphere and troposphere. And it will make those corrections available in real time, as well as in post-processing mode. So introduced was that in 2011. And now when I say post-processing mode, then we call this POSPac Post-Process Trimble Center Point RTX. Again, it relies on the generation of all of these information from the precise orbit, clock information, et cetera, et cetera. It does leverage all of the satellite navigation systems. And at the end, that PPRTX, so post-process RTX, is really a cloud-based global GNSS correction service that does utilize the Trimble RTX technology to provide you with a centimeter level post-processing positioning. Again, that means we don't need any base station for that type of processing. And the corrections are available within minutes after the mission completion. So that makes PPRTX a really powerful processing mode or alternative processing mode to the legacy processing modes like single base or smart base processing. So the Trimble Center Point RTX services are split into two regions. We do have the FAST region, which is in Central Europe and North America. And we do have a global region, which is basically the rest of the world. Global region corrections are based on a global ionospheric model, while the FAST region uses a denser network of reference stations to compute a regional ionospheric model for atmospheric corrections. Anyway, the PPRTX in general is covered really globally. It's just all connected to how quick a solution can converge. And when I say how quick a solution can converge, it means when it does reach a certain level of accuracy. So in the FAST region, we have a little quicker convergence time, which is around 1 to 2 minutes for all the satellite constellations. And in the FAST region, it's a little slower, but it's still below 3 minutes. And that's really fast enough in the global region to get a decent solution. The assumption, however, is that we really leverage all of the signals and satellites, specifically the Baidu 3 generation signals. They are very important to improve the convergence time for the PPRTX mode in the global region. Now let's get to the business plan and the supported plans that we have here. So first of all, we still have a free trial plan, and the free trial plan includes 3 tokens. A token translates into a mission, and it grants 1 mission load into POSPac Assure, independent of the mission length. And 1 mission is basically 1 log of consecutive GNSS INS data without any data caps. That's a free plan. Now the first subscription plan that we offer is the so-called base plan. The base plan, it's a monthly subscription that supports the features real-time QC and calibration mode. And it comes with so-called 10 tokens. Again, that translates into 10 missions. So the user can process 10 missions on a monthly basis. Reprocessing of the same data is basically free of charge. So in case of you detect a problem with a certain data set, you want to upload the same data set again, we are not going to deduct any tokens during that period. And this plan is upgradable to the professional plan that you can see in the middle here. The professional plan compared to the base plan supports also the ground truth feature. So basically all the feature that I have presented so far. Same here, 10 tokens are included. Reprocessing is free of charge. And the plan can be downgraded to the base plan at the end of this monthly cycle. Now, should the 10 tokens not be sufficient for you, you can purchase so-called add-on plan. And that will deliver you a quantity of 10 token packages. Really depends on how many packages you want to purchase. Well, 1 package includes 10 tokens. So you can purchase many packages. And the more you purchase, the higher is the discount. We go up to 25% discount for the add-on plans. The difference here in terms of the tokens and the usability of the tokens is that for the add-on plans, the tokens are valid for a period of 12 months, whereas the 10 tokens from the subscription are obviously reset at the monthly cycle. And just to say, so the subscription is obviously mandatory before you can even purchase add-on plans. So customers who have interest to purchase X amount of tokens for post-processing purposes or for real-time QC purposes, whatever, they at least need to have a subscription running. Okay, let's get to the report and analysis. So after you've submitted your project, you're going to get your project in a zip file and you want to analyze it. And quite important is the report PDF file that I mentioned before. And for instance, if you run the calibration mode, you are obviously interested in the calibrated lever arms, for instance. And they are available in a table. And you can see here the green marks. And above there's a white line. So these are the initial values. And then the green one gives you really the calibrated values. So first one is the GNSS lever arm that typically goes from the reference point, wherever that is defined, to the GNSS antenna. Then we have the ones for the DMI that goes from the reference point to the DMI. That's where the tire touches the ground typically. So you have the X, Y, Z value, and you have also the scale factor. The scale factor translates the number of pulses into a driven distance. And then if you operate with a 2-antenna system, then we speak about GAMS here. So the GAMS lever arm is basically the vector between both antennas, antenna 1 and antenna 2. And that's also presented in a table form. Another interesting plot may be the GNSS QC statistics. GNSS QC means that it's just the GNSS only processing where the rover data are merged with the base station data, or the rover data are merged with the PPRTX correction service. And what's obviously interesting is you want to see in a decent, good environment, specifically if you do calibration, for instance, that you have a high number of fixed epochs. When I say fixed epoch, that relates to the ambiguity solution of the GNSS only solution. So in that case here, we have almost 99% of a fixed solution. Then we have a certain amount for the float and for no solution. So really depending on the application and where you drove the data, that can be very helpful to assess the quality of your trajectory. Another interesting plot is the RMS value, so the accuracy after post-processing. Of course, you have also plots for the accuracy during the real-time application. So you can look at the position like 3D north, east, down, accuracy estimated over the time of the mission. That's presented on the left side. On the right side, just an example for the heading RMS value. Of course, you can also look at your roll and pitch values, but the heading is typically the most sensitive angle when it comes to GNSS INS post-processing. Another interesting angle here is the heading bore sight between the vehicle and inertial measurement unit. So bore sight means like a misalignment. So there's going to be a misalignment between the vehicle frame and the inertial measurement unit frame. That is more really relevant for the autonomous or robotics industry, not so much for the mapping industry, because you want to relate, in the mapping industry, you want to relate everything to the reference sensor, which could be a camera or LiDAR or whatever. And then another example here is the so-called total acceleration. The total acceleration helps to identify platform integration issues related to vibration. So typically the total acceleration should be around 0 to 0.5 G. That's kind of normal. However, if the overall plot leans more towards 1 G and appears biased, or if there are too many peaks over 1 G or even higher, it could indicate a vibration problem, right? And excessive platform vibration means that the platform's true motion may not be sensed, and therefore the GNSS INS solution becomes decoupled from the reality. High vibration should be dampened. For more details, I'd suggest to study the tutorial that you can access from the landing page or from the web application itself. So these were just examples. Again, there is far more plots available. And yeah, again, so they're all very well explained in the tutorial that you can access. So additional features, just want to emphasize this one here. I mentioned that before. So in case of you bring your own base station and you pitch your base station, for instance, in the field, or you got your base station from somewhere and you don't trust the coordinates, or you don't know the coordinates even, you can use that survey, that RTX survey in functionality. So if you load your base station, just click on RTX base station and it will automatically survey in the coordinate of the base station. So you're going to get a precise coordinate as a reference, and you potentially also remove any datum shift concerns. That's always a problem when it comes to base stations. Sometimes you don't know, what is the frame that the coordinates are in. Like, is it WGS 84, or is it ITRF, or is it ETRS 89, et cetera, et cetera. As soon as you use that RTX survey in function, that concern moves away because we have full control over the datum, so over the frame. So at the end, that runs like a static RTX processing. And again, that's also available minutes after the data collection. And we're supporting the standard Trimble formats like T02, T04, but also the Rhinex files, version 2 and version 3. Just one word of caution is the antenna that's being used need to be a calibrated antenna. Only then we can also guarantee a certain coordinate performance during the survey and functionality. Now, the other thing is the TGAP app. I think I mentioned that already. This is an exciting free of charge tool. It's also a web application. So TGAP stands for Trimble GNSS Augmentation Planner. And at the end, that does visualize all of the Trimble correction services worldwide. And we're supporting more than 13,000 reference stations from 40 networks in about 160 plus countries. So this web application is also pretty simple. You can draw your area of interest, or you load a raw T04 file or a POS file, a kinematic Rhinex file, KML shape file, ASCII file. There's a bunch of files that we support. You just load that into the app and you will immediately see what base stations are close by, and what base stations you can leverage potentially in POSPac Assure, but also in POSPac in general. And at the same time, this app will also make a proposal of what is the best processing mode in POSPac or POSPac Assure. So this kind of app is even kind of integrated in POSPac Assure. So when you see the map and the trajectory that's overlaid, it will also automatically make a suggestion for the post-processing mode. But this is the standalone tool that you can use like ahead of time. For instance, if you know I'm going there next week or in a month, what is the availability of correction data? You can use that standalone tool anytime you want. Now, the last one here I'd like to emphasize is our POSPac Cloud API. So this is definitely more for a tighter integration, let's say for fleet volume processing or for OEMs who want to integrate that into their own software application. And those customers can use the POSPac Cloud API. And there's two platforms here, two environments. One is the staging environment where customers can test the integration, they can probe the integration, etc. And then once they go live, they move over to the production environment. The cloud environment is monitored 7/24. It's a very redundant environment, and customers can even make a health check. So we have a status page where customers can subscribe to. So they are going to be notified about maintenance windows, about patching windows, downtime windows if they really occur. But they can always go there and make a live health check. So this, again, as I said, more for high volume data processing. And in terms of the business model, we pursue the idea of a pay-per-use model or subscription model. Okay, that brings me to the summary and then the demo and the Q&A session. So short summary here, POSPac Assure is an easy-to-use web application for GNSS INS integration and performance checks, including the option to generate ground truth reference data. So that brings me to the live demo. So I would hand over now to Henny and stop sharing my screen here.
Great.
And
Thank
Henny,
you, Nico.
you're welcome to continue from here.
All right, perfect. Thank you, Nico. I'm going to share my screen and kick off with a quick demo. Okay, so to get started, Nico said we do have a free trial. You can head over to Applanix POSPac and you'll land on a page like this. You can just sign up for a free trial here. I already have an account, so I'm just going to go ahead and log in and show you what the application looks like. So to get started, it's simple. You got a map view here. You can either drag and drop your rover file, which I'm going to do right now. I'm going to go ahead and grab my T04 file and just drag it onto the map. It takes a couple seconds, depending on your data set, to load up and visualize your data. Like Nico mentioned, this is using our Trimble, our TGAP, our GNSS Aug Planner tool embedded right into POSPac Assure. And so you can visualize your trajectory and any surrounding base stations and other services, including PPRTX. You can zoom out and kind of get a good perspective on what stations are around or what services are recommended. It is going to recommend a mode, but you can obviously override that down below. So if I just go ahead and switch the three modes that Nico talked about in the real-time QC mode, calibration mode, and ground truth mode. So for this demo, I'm going to go ahead and choose calibration, and I'm going to switch it up from PPRTX and just provide my own base station. So I'm going to choose single base. And again, I can drag a file, or I can just go ahead and just click browse and load up my file. And that's it. The RTX base station position is going to compute a position automatically. I'm going to use that as my preferred mode and just hit submit. Takes a few seconds, and it's going to submit the project up to the cloud for processing. And once it's done, it's going to pop up to say it's successfully uploaded. You can go into the menu on top right here and go under the project section and kind of see the status that it's processed, or sorry, it's processing, and details about your project. So you can just kind of refresh and you get the updated status. So it's going to take a few minutes to process, but I've already processed this project before, so we can go ahead and show you what it looks like. So once it's successful, you'll see a download button. You click download, it's going to download a zip file for you, which contains logs and PDF reports and everything Nico talked about, your real-time navigation solution. So let me just flip over here. I've already downloaded this prior, and this is what it looks like. Here's what the results that you get. So you have log files, KML files, you have your real-time navigation solution, and probably the most important is your PDF file. So this is where you get your calibration lever arms. I have the PDF open here. So this is, Nico can help me walk through this, but these are the stats that Nico showed a few minutes ago. Yeah, you got your GNSS stats here.
Yeah, let's look at the calibrated installation parameters because that was a calibration mode, so that's probably most exciting. So you can see there the table of the initial GNSS lever arm, and then the iteration 1 reference to primary GNSS lever arm. That is basically the calibrated lever arm. So you have again the initial start values and then the calibrated values as a comparison. That was for the GNSS to reference to GNSS antenna. Now let's switch to the GAMS, which is the 2 antenna solution. Same here, you have a table form with the initial values or original values, and then the calibrated GAMS lever arm. And then last but not least, we also have the reference to PTMI lever arm here. And that gives you not only the lever arm, but also the scale factor. Same here, original and calibrated is pretty well documented in here. And the other thing, I think Henny was under rover data QC that we wanted to show, which is the, if you populate that one. And then the heading bore site between vehicle and viewframe, that's also what I presented in the presentation. So if you scroll down here, so again, that might be mostly interesting for the autonomous industry or robotics industry, where it's important to understand what the difference is between the inertial measurement unit that you have installed versus the vehicle frame, because you want to reference probably everything to the vehicle frame. Again, for the mapping industry, that is not so exciting, because in the mapping industry, you want to reference everything to the sensors. That could be like a LiDAR system or a camera system. And there, the bore set angles refer rather to those sensors. That's not going to be part of this session. I think for the calibration mode, that's sufficient here, Henny, so you can proceed and demo the ground truth.
So once, we're going to go ahead and show you. It's the same process to do the ground truth mode. So same idea, you can go back and either drag and drop your T04 or POS files. I'm just going to drag them in. It's going to take a few seconds. Like Nico mentioned, you could, by default, it uses your file name as your project name, but of course you can customize the project name the way you like it. And we can, obviously choose whatever mode you want. I'm just going to give it a few seconds to load. Depending on the data set, it may take a few seconds to load, extract, and visualize the data. So I'm going to switch over to to ground truth mode. And this time, I'm going to use the RTK corrections that are logged with the data. And same idea, just hit submit, and project is kind of gathered, prepared, uploaded to the cloud for processing, and you can check the status of the project just like before. So this time, I've already ran this project again, so I'm going to show you what the results look like for ground truth mode. They're very similar. I mean, obviously the exception, the biggest difference is that you get an SBET file this time with your mission.
Yeah, and you have also an ASCII file along with this, Henny. So
yes, we have.
So
the
there's
KML
also
file.
on top,
and
I think there's the ASCII file, which is a generic ASCII file that contains position orientation information and the time tag. So that's also delivered along with the SBET file, which is a binary file format, right? And this is an ASCII file.
Correct. Yeah, this is the ASCII version of the SBET, basically.
Mm-hmm.
Yeah, that's basically it for how it works. Just one thing I wanted to point out is we do have a tutorial inside the menu. Top right, click tutorial. You'll see a PDF version. It's a very intensive tutorial that Nico put together. It explains everything in full detail here. Obviously, you can visualize it here, or you can download it so you can have it visualize it offline. And yeah, if there's any questions or issues, you can always send an email to our support team just through this chat widget down. Excuse me, chat widget down here. He'll send an email to our tech support, and he'll respond via email. And yeah, so there's a free trial to get you started.
Yeah. Maybe, Henny, you want to open again this report from the ground truth because there's some more plots. Maybe we want to show our audience one or the
Yeah,
other
let me
plot.
open up the report for.
Yeah. So this one here, we should have what's most interesting is obviously if you post-process your solution, so you have the smooth trajectory data, you probably want to see the performance of it. So if you and go further down, you have smooth performance metrics, Henny. Yeah. So for instance, here you can plot your position error over time in north, east, and down. So you can see very often we have 1 to 2 centimeters, and then it peaks up to 1 to 10 centimeter. And there's a bigger one that goes up to 30 centimeter. So that is either now a very difficult environment, or in this case, we use the RTK corrections, so the real-time corrections, but there was a dropout. We lost the link to the server that provides the real-time solution. That's where we are seeing that the solution does degrade a little bit, right? So this smooth performance matrix is interesting. Obviously, you can also look not only at position, but also at roll pitch and heading RMS. If you want to show that quickly, yeah, here they are. So roll and pitch is plotted in one plot, and then we have the heading, which is further down here. And another exciting one should be under IronFusion QC. Can you check that handy for me? IronFusion QC is the, can you open this up? Because, yeah, the SBET IA car separation, for instance. So that is also a very interesting plot if you want to analyze your data, because it tells you what is the difference after post-processing between the forward and the reverse solution. So when we post-process the data and we smooth them, we always like process forward in time and backward in time. And the position plot here shows you really the difference. So that means you can identify, let's say, critical areas where the forward solution does not aligns pretty well with the backward solution. Well, in this case, it correlates kind of with the RMS values that we have seen, because we know, okay, we lost like the GNSS correction data for some time. But again, it's a good window, it's a good plot to find the spots where you have some issues. And then there was the, if you go further up, Henny, there was also a plot that shows the difference in the between the real-time solution and the post-process. There could be rover data QC. Rover data QC, is that the one? No, it's not the one. Okay, let's skip that. Is there a lot of plots in here? So, oh, here we go.
Mhm.
Smooth navigation difference. Here we go. That's the one I wanted to show. Yeah. So you have the north position, east position, and down position. So that basically really plots you the difference between the real-time solution that the system did process during the real-time data acquisition and the post-processing mode. And we can see here huge differences because, again, we had some issues with the RTK, etc., and the smooth solution is always better, but it gives you like a feeling how well you improve, for instance, your solution. How good is your real-time? How good is your post-process solution? So that's always running at the same time. when you submit a project in ground truth mode. Okay, so I think that should be it in terms of the PDF reports here and what's delivered. As Henny said, we do have the tutorial there that goes more into details and helps you to understand all the plots, and eventually it does assist you to understand the quality of the files that we deliver to you.
Yeah.
Okay.
Perfect. Yeah, in the tutorial link, we have access to your projects, and here's where you can manage your account in terms of upgrading, downgrading, buying more tokens, etc.
Okay, great. Then I
Yeah,
think you can stop sharing. I share my screen again. And that brings us already now to the questions. So if you hadn't gone there under the Q&A box, you can enter your questions. Please do so. Now my question to Henny is, are you seeing already some
yes,
questions?
we have 6 questions so far, so I'll just go in order as they came in. So Brett was asking, is this an indoor solution?
No, this is not an indoor solution. So again, it is a web application that does help you to evaluate GNSS INS data from our real-time products from the business line land and marine, but also our direct georeferencing products from land and marine, and for the PX1, which is the from the airborne mobility sector. So it's nothing for indoor right now. No.
Okay, and there's a follow-up question. Is Brett's asking if we can build the solution with our in-house data center.
Say again, Henny, what?
Yeah, he's asking, can we build this solution with our in-house data center? I mean, I think we don't really have an API for this. It's a web-based tool that can be used kind of
okay.
project by project
That might
basis.
that might be the question. Yeah, I mean, the POSPac Assure web application does leverage our POSPac Cloud API, right, in the backend. So again, customers who want to have the tight integration in their own software with their own features, they can leverage the POSPac Cloud API rather than the web application. Because the web application is really, you open the browser, you sign in, you log in, and you do everything right on that browser site, right? That's what the web application is. Tighter integration, again, goes through POSPac Cloud API.
Right. Okay. There's another question is asking, does the ground truth export RMS and SBETs? And yeah, the answer is yes. Yeah, you have the SBET and you have the RMS file in the standard POSPac output in the binary format.
Yeah, correct.
And
This is I think that refers to the SMRMSG file. This contains the RMS values, right? So this SMRMSG file is also delivered as part of the zip file. Yeah.
Perfect. And then I think his follow-up question is, can you export the SBETs and RMS in custom mapping frames?
No, that is not supported right now. That's what I said. The interaction on the web application is very small, and that's what we wanted. That's what we wanted to do. So we wanted to keep that easy and simple for customers. That's why I presented the table, so you understand what the frames are. If you choose a certain processing mode, the user can right now not select the frame.
Okay. And what's the difference or advantage between Assure versus POSPac, the full POSPac MMS?
Advantage of POSPac Assure over POSPac desktop,
or the differences,
or vice versa?
Differences or advantages of I guess differences between Assure compared to the full POSPac MMS.
Yeah, of course. I think I kind of presented that. So POSPac MMS is just a desktop software. You need to install it. You need to deal with licensing. You need to keep it updated. You need to pay for maintenance, that kind of stuff. But obviously, you have more functions and you have more options. You can use your own custom format when you output something. You have more control over the mapping grid, over the frames, etc., etc. Whereas POSPac Assure is, again, simple, easy. It's a cloud solution. no on-site installations, no maintenance, no updates that you need to worry about. Everything runs really in the cloud, and it's very easy to use. That is, yeah, I think that summarizes it pretty well.
Yeah, and then this is designed for the land-based products as well. Like it's a limited, you can't run all the types of projects under the POSPac Assure.
Yeah, correct. As we said, so we're supporting really the business lines, land and marine, and one little portion for airborne, but for instance, not other airborne products. And the POSPac desktop, really, you can process any of such data. So the POSPac Assure is kind of a limited thing, obviously.
Okay, perfect. And then Derek's asking about the pricing. I don't know if you can bring that pricing up. So he's saying, what is the price for the token package add-on? Say we need to process 30 extra minutes per month. So yeah, if you can bring up that slide again. Yeah.
So standard pricing for the base subscription is $38 per month. It does support real-time QC and calibration mode with the 10 tokens. And then we have the professional, which is $99, and that includes ground truth. Now, add-on plans start from the same pricing, but they are discounted. Well, we don't have a table right now here, but significantly discounted. So you can say, like, if you purchase multiple packages of tokens, then you have a 25% discount, for instance, for the professional or and base plan. Do we have a better table form available, Henny?
I was looking. No, I do not. But within the app, you can see the exact pricing, but it does start at the same pricing as the subscription, right? Like
right.
For
the first package, yeah, I'm not sure, but for the first package, it starts almost with the same pricing. But then if you purchase multiple package of these 10 token sets, then again, it gets discounted, and you can see that inside the web application.
Yeah, perfect. Yeah, on the accounts page, you can see it. And it depends. Like the basic tokens are less expensive. So the basic tokens correspond to a basic plan, and if you want the ground truth, you need the professional subscription. Then you need to buy professional tokens, and those are more expensive than the basic tokens. So you have to match the tokens with the plan that you're currently on. And they are, like Nico said, discounted. There is a tool inside when you go buy it. It'll calculate for you based on if you want 10, 20, 30, or 100 tokens. It'll give you the price kind of discounted already. Okay, and then last question is could be similar to the previous question. It's from Sam. He said, sorry, he joined late, but POSPac Assure, is it the same as the current POSPac 9.1 software? I mean, in terms of engine, it's running the latest, and the cloud POSPac Assure is running the latest official version. I think it's 9.3.
Yep, correct.
I believe. Yeah. So it's maybe you can explain again just real quick. Assure is not really meant for full processing. It's meant for just like QC checking and ground truth and calibration. Like it's not meant to replace your POSPac for heavy operations.
Yeah, especially if you're in a production environment, in a high volume production environment, then of course, POSPac Assure is not the right answer. But if you want to produce like even ground truth data, like on like one mission on a weekly basis or bi-weekly basis, or even on a daily basis, one mission is not a big deal. You can just go through POSPac Assure. But as soon as you're in a production environment with a fleet system, so you have a fleet of systems that collect data daily, you know, that's not the answer. That software is not the answer for it. You better use either POSPac desktop, or you adopt to our POSPac Cloud API, where you have more control over all the processes, over the formats that you want to output, over the frames, the mapping grids, GeoEat models, all that kind of stuff.
Yeah, perfect. That's it for questions. Everyone's welcome to ask more questions in the question box below.
Okay, if there are any questions coming in, we can also follow up later on. So I think we're good for now. We have the hour, 60 minutes now. So, well, so that brings us really to the end of the webinar. Thank you very much for your participation today. We appreciate your attendance, and please do not hesitate to ask any questions you may have. Try POSPac Assure and give us feedback to trigger product improvements in the future. So we are very willing to learn, and we hope to see you soon in a future webinar. Thank you very much. Take care. Bye-bye.